Hi everyone, it's Has. Today I'm going to continue with the Abaqus video tutorials. So today is going to be a backing analysis. So first of all, I'm going to create my geometry so I can follow with the rest of the video. So first of all, I'm going to click on parts here. Normally, when you open your Abaqus, you have parts in here. So you have parts, and then you click on here, create a part. You can give a name, let's say a plate, because this is a plate. So I keep it 3D, but here I will choose shell. Instead of solid, I will choose shell because I want my plate to look like a 2D dimension, but then I'm going to attribute a thickness. So I can't choose 2D because if I choose 2D, I can't attribute a thickness. But here I can choose shell to look like 2D, but I'm going to tell my software that I want to give you a thickness to consider it, right? So now 3D deformable and then shell planar. Continue. So now I can create my geometry. I'm going to click on this, create lines, and then I'm going to create my plate. So this is a rectangle because the plate looks like a rectangle. Now dimension here is going to be 35. I'm going to give 35, and here is going to be 55. 55. So now we're good. We can go on properties. No. Before I go on properties, I need to finish here. I need to click on done. So now the geometry is created. Okay. Now I can go on property. Is the second step. I'm going to create here new property. So I can give steel because this is a steel. So now mechanical elasticity, elastic, and I'm going to give the Young modulus, which is 210 E03, 10 power 3, because it's in megapascal, right? And now for the question ratio, it's going to be 0.3. Now, okay. So you can click on here, the monitor or the manager, and you can come in here and you can see the material that you created. Yeah, so now I'm going to create a section, right? You create a section in here, and I'm going to leave it as section 1 and here as shell homogeneous. Why homogeneous? Because it's an isotropic material, it's a steel. So now continue, and here I'm going to attribute the thickness. The shell thickness, I'm going to put 0.5, and now everything is fine. I can click on OK. So that is the section that I created, but I didn't apply yet to my geometry. So now I'm going to click on here, assign section, and then click here and done. So now I'm going to choose which section I want to apply or attribute to my material or to my geometry, and it's this section that is already created, section 1. And then I can click OK because it's in default as we only have one section created. So now OK, we can see the change of color. That means it's being applied. And now I can go on assembly because it's a rule on Abaqus. You need to create an instance here. So you need to click OK. So now an instance is being created. If you want to see it, you can come here at assembly, click here, instance, you have plate 1. So instance 1 is created, the instance. So now you can go on step. And whatever you do, you need to create a step. So for the step, I'm going to click on here. That's how you create the step, create step. Here you have step 1. General, I'm going to change it because if you see in general, I can put direct cyclic and have dynamic, heat transfer, solid static general, but I don't see buckle or buckling. So I can change here into linear perturbation. So now I can choose buckle, right? So that's represent the buckling analysis. And then I can go and continue. And now here on the maximum number of iteration, I can put 300, for example. Now vector use per iteration, I can choose 10, think it's fine. And number of eigenvalues requested, I can request, let's say 5. 5 is fine for this. So in other, there's nothing to do in here. Symmetric, the massive storage, always this. And that basics, I can click on OK. So now we create our step. Okay, now I can go on iteration. I don't in interaction. There is nothing to do as we have only one part, so it's fine. Now we finish with this. We can go on loads. So this is the boundary condition. The boundary condition. First of all, I'm going to constrain my plate down here. So down below, I'm going to apply a fixed support. To do it, you need to come out here, create boundary condition, and then I'm going to give a name, fixed support. So now I can choose, yeah, this one, symmetry, and then continue. I'm going to click on here, down here, and then down. I'm going to choose encastre. Encastre means fixed support. You block all the translations and all the rotation. You click OK. So now you apply the encastre. Now you are going to apply the loads. I create loads in here. I'm going to give the name of shell edge load. I'm going to give load in here. So shell edge load, continue. I can click here, upward here, and then down. So now I'm going to give a magnitude, right? So the magnitude that I'm going to give is 1, and then I can click OK here. So now I apply the load. What I can do right now is, I think we finished everything. I already applied the load. Now we can go on job. So before we go on job, I want to create the mesh, right? So I could have created the mesh before applying the boundary conditions, but it's fine. We can do it right now. So mesh, I'm going to click on here. Part instances cannot be edited or assigned mesh attribute. Yeah, because here it's assembly. We need to go on parts. So now it will work. So here approximate global size. Let's take it as it is on default 5.5. I mean, I can put 1 and stuff, but it will have so much time of calculations. I want to reduce that. So let's say, okay, here, and I can click on done and then come out here, generate mesh part, and then yes. So I have my mesh, right? So what I would do right now is to go on job because we finished with the mesh job. So I create a job. I can give a name. Let's say buckling analysis results. That is my job. And then I'm going to continue here. Dismiss job name must be 180 character long. Yeah, okay. So let's say it's really, really long. Let me do this buckling analysis. Let's say here I don't give a space, I give this, the underscore, and then continue. Yeah, everything is fine right now. I can go on OK. And then I can come out here, the manager, the job manager, and now I'm going to submit here. So if I submit, you can see that the simulation is being running, right? And it's submitted. So now I can go on, as it's submitting, it's running. Here we can wait a couple of minutes in order to see. So it's already completed, right? And then I can go on results. So on results, I can click on here. I can see the magnitude in here. So now as we can see the results, we can go on here, option, and then common here. And then here, I think I can change something. I can change this auto compute into uniform. So I can give a value. So it's 5. Yeah, we're fine. It's 5. I can even cancel it. I don't need to pull, I thought it was 1, but it's 5. So it's fine. I can come here and click this. You can see this is the animation, right? You can click on here and you can see how the plate will be unbuckling. So you can see how it is. So you can come before, you can turn it and click here and see. So that is the way you do a buckling analysis on Abaqus. I hope that helps, guys. Don't hesitate to subscribe and to like the video.